Okay, so as in the last video we have discussed about the series combination, or we can say that capacitors in series, right? Series was nothing but it was used for the same path, right? So we discussed or we understood the diagram of the capacitors in series or series combination, right? We placed three capacitors C1, C2, C3, right? When two or more capacitors are connected one after another. See, there are two or more than two, right? Here we have more than two, means we have three capacitors here. So they three are connected one after another. This connected here, after that this connected here, right? So they are connected one after another in the same path. As you can see, the three are connected in the same path. So this such type of combination is what we call the series combination, or we can say that capacitors in series. Then we understood the diagram of series combination or capacitors in series in very detail, right? We considered three capacitors C1, C2, C3, right? We considered three capacitors C1, C2, C3. They all were connected in a series. See, series means same path, and the three are connected in a series means they three are connected in the same path across a positive and negative terminal of the battery of potential difference V volt. They are connected with the positive and negative terminal of the battery with provided potential difference V volt, right? Here we have V volt. Then the potential difference across any member of the capacitor is different, which means the potential difference which will be provided to the C1, C2, C3 would be different. However, the charge they're gonna store would be same, right? Now what we discuss, I'm just going to write that down, right? Initially we consider three capacitors C1, C2 and C3, and they were connected in series, right? Are connected in series, right? Across positive and negative terminal of the battery. Positive and negative terminal of the battery. Right? Battery of potential difference V volt. Potential difference V volt. Alright. The potential difference then was provided to each capacitor was different, which means the potential difference across any member of capacitor is different, right? Different, right? But charge would be same, which will be stored by these capacitor. So same charge is stored in each plate of the capacitor. Charge stored on each plate of the capacitor, right? So let's read this once more so that we can have a more idea about this, right? We considered three capacitors named as C1, C2, C3, and we connected these three capacitors in a series, which means they are connected in the same path across a potential difference or across positive and negative terminal of the battery with potential difference provided V volt, right? The potential difference across any member of the capacitor is different. that potential difference would be different, but the charge stored on each plate of the capacitor would be same. Alright, now according to this equation, we are going to define this equation in the mathematical form, right? So according to the equation, according to this equation, we initially we know that Q is equal to CV, right? Because we were known that the charge stored on the plate of the capacitor would be directly proportional to the potential difference provided to it. When we remove this when we remove this proportionality sign, we got is equal to sign with constant C, where we got that C was our uh, constant, which was known as capacitance of a capacitor, or the ability of the capacitor to store the charges on it, or it was the ratio of charge per unit potential difference, right? Here we need to find the V, right? Because potential difference stored on the each plate of the capacitor would be different. So V is equal to C is multiplying with V here. When we will go there, will be divided, right? So Q upon C, right? But if you are finding the potential difference which will be provided to this first capacitor C1, then the equation would be V1, because we are finding the potential difference for the C1, right? Q upon we are finding for the C1, so here it would be C1, right? This would be the potential difference for the first capacitor, right? Then if we are finding for the second capacitor, there will be V2, since that will be potential difference 2 upon charge we have already discussed. Charge stored on the each plate of the capacitor would be same, however potential difference across any member of the capacitor would be different. So we are finding here the potential difference, charge would be same on the each plate of the capacitor. And of course if we are finding V2, so that would be of C2, right? C2 means capacitor number 2. So let me highlight this. Then we are going to find the potential difference of the third capacitor, right? V3, that would be Q per unit C3, because we are finding for the third capacitor, right? So here we have got our potential difference of the third capacitor as well, that is equal to V3 is equal to Q per unit C3, right? Now if they are asking you the total potential difference on each plate of the capacitor, then you need to add all these potential differences, right? So wait, now basically I'm going to find the total potential difference, potential on each plate of the capacitor, on each plate of the capacitor, right? Plate of the capacitor of the capacitor, right? So we know that we have already found V1, V2, V3. Let's add these, right? Because we are finding the total potential now. So Vt, which is representing the total potential, is equal to V1, which is the potential difference of the first capacitor, and that will be equal to Q per unit C1, right? V2, which is the potential difference of the second capacitor, and which is equal to charge per unit C2, and V3, which is the potential difference of the third capacitor, which is equal to charge per unit C3, right? So this is our final equation where we will be finding the total potential, right? So now in today's video we have basically derived the mathematical form of the definition of the series combination or capacitors in series. In next video we will gonna find the equivalent capacitor as well, what is that equal to, right? We're gonna discuss each and everything in very detail in the coming video. So in today's video we just derived the mathematical form of our this equation, and this equation was basically we considered three capacitors C1, C2, C3, and they were connected in series with positive and negative terminal of the battery of potential difference V volt. Then the potential difference was different on each member of the capacitor, but the charge was stored same on the each capacitor, right? So we know that potential difference would be different, so we derived how to find the potential difference on each capacitor when there would be different potential, right? In next video we will be discussing about the equivalent capacitor. This was all for today.